Matug acceptance.
Okay, hello. Hello on our presentation. Today, with Robert, we like to speak about the artificial intelligence project and what you need to know to make this project successful. And what is the background of this presentation? With Robert, we are working in the UBS and working in the AI and data scientist team. And mostly from the 2 years, we are working on in the team where we are implementing the artificial intelligence solution in the large investment bank. And in our role, we met many of the projects, mostly in the NLP space, but not limited only to that, and gain some of the experience about the critical success factor to put this project on the production. And today we like to give you some of the clue and give you also the information about which area should consider before you start that kind of project and increase the chance to have success in that area. Okay. Let's start. Let's go. In many companies, starting from the inspiration, somebody say, okay, we like to do something with the AI, or we hear the AI is the great thing, and we should try. Or maybe the AI can solve all the problems which we have in our business domain. And that is started. Our mission is launched. Everybody is excited. The developers also, in many cases, say, "Oh, great! We have the occasion to test that kind of approach." Everything looks smooth. On the beginning, in the most of the projects, everything look okay. But in one of the moments of the mission, we have the problem, and the problem. Say something, okay, we are not going in the direction which we like to have in that project. And in with our experience which we had during our delivery, this is happening often. And regarding to the data which comes from 2018, only the 10% of the machine learning reach out the production state. That means in 9 from 10 samples, the project which somebody work on is never hit this state where bringing some of the value for the company. And probably now the numbers are slightly better because it's coming from 2018 and many things are happen to increase that state. However, still in many cases this machine learning project is failing. Okay. What you should consider to make the mission successful? We're starting our presentation here. And that is a simplified process or the simplified way how we deploying the production, the machine learning model in the production. And of course, this is a simplified process. This is not something, if you're going the real product is a little more complex, but in terms for the simplification for that presentation, we split this on the three phases. The prepare phase, that is before you start working on any code. The build, where somebody is working on with the data and preparing this launch of the project, and maintaining, where you try to keep the solution ready for robust and still working on the production without any problem and any harm. And below that presentation, you have these two approaches, which SDLC is probably common for most of the you, because if you are the developer, you have the normal software development life cycle. Plus, now we have the younger brother of the SDLC, and it's MLOps, regarding to the life cycle of the models. And you should consider both of these approaches during the process. And on the top of that process, you have the user experience, which means in that case, everything what you're working on and you are producing any kind of solution on the end should bringing the business value and should be good for your customer and your users. This is not equal, but on the end you should achieve the good results on the end. I focus on the prepare phase. Robert focus more on the build and maintain, and on the summary, we give you I think one of the most important clue what you should do if you like to have the successful model or the successful solution regarding artificial intelligence product in your space. Okay, the first thing, somebody, as I say on the beginning, somebody say in the company, oh, we should take the ML and make the magic. And it's in many cases the people who not understand the machine learning or go to the conference, go to the different business, especially if coming from the business domain, or this is tech management. We say, oh, okay, that is something we should try. But on the beginning, if you consider any kind of project with the machine learning, thinking about what is the real output of this project and what you should have on the end. And not thinking about the technical side of this project, but what this application should do. And machine learning in most of the cases, especially if you're working in this environment, the corporate environment or the enterprise environment, is narrowed down to the labeling. You have, by example, the fraud detection system, and the system on the end say, okay, this is fraud or not. And you have the label on the end. If you good to understand the customer, from who is coming to you and bring you this product, or what is the business need behind, and how the model or how this solution should be exposed on the end. And if you define that one and reduce this magic on the beginning, because many people say, okay, I have the problem. I don't really know about what I'm expecting, but I hear the machine learning can solve that problem without even definition of that one. And try to make this feel more explicit what you like to do with this kind of application. And if you understand that one and you know what you like to do, think about the machine learning is really mandatory for your project. And machine learning is good from some of the area of the problem solving, but not all of them. And this is a few clue what you should consider, or how we can help you to navigate, okay, this is a potential machine learning project, or no, we should say, sorry, the machine learning is not a good solution here. Recommendation, the suggestion, language understanding, anomaly detection, personalization. In that case, if you are working with a big size of the data and the heuristic is too complex to create and maintain, maybe this is a potential information. Okay, maybe machine learning can be something which you can solve that kind of problem. Machine learning work very well where you're thinking about to help the users to achieve the goals in the application, or you have a customer to achieve the goal, help these users, but rather than they replace completely the humans. I speak more about in the one of the next slides, but in that case, this is a potential good place for the machine learning. And thinking also about the scale. That means if somebody say, oh, we have the one of our problem and we like to trigger this one time, maybe the machine learning and bringing all the complexity of putting this model on the production is not worth to creating that kind of product. Maybe better is go to the simply analytics, go to the data scientist, prepare one of the report for the management or the customer, and that is enough. This is big, and what is the potential yellow or the red flags if you thinking about the machine learning project? Good to ask the people they understand the machine learning and understand the machine learning not giving all the time the 100% accuracy. On the models always bringing some of the errors, some of the mistakes, and if you like to have them less mistakes, the creation of that kind of model is more expensive because you need more data, more testing, and ask your business, ask your customer, or if you have that kind of occasion, they understand the model will not giving always the perfect match. If logic requires complete transparency, this is also the potential yellow or the red flag. Some of the business areas are highly regulated and expecting everybody knows what is happening in the application. And if you are using the models, that is not in most of the cases something which you say exactly, okay, from why is the reason why this model behaving that way. Of course, you can bring in some of the terms like the explainability, but not giving you the perfect business logic representation. For example, you can code if you going with the normal paradigm of the programming. And thinking about you have the data, because without the data you cannot have the machine learning. And no ML, no data, no ML. Of course, you can provide the workarounds for in that kind of situation. You can buy the data on the market. You can provide some of the transfer learning, and, for example, take the model from the market. You have the pre-trained model. Everything can be helped here, but thinking about on the beginning, you have enough data to work with that kind of project. Okay, if you say that machine learning is something which can potentially help you, thinking about how you like to measure we are doing the right thing in that kind of application, that kind of solution. And I call this universal performance metric, and that not is equal for the measurement of the model performance. That is thinking rather your application, your business goal which you like to solve, or what do you like to that the business expecting from you from this machine, help you say, okay, we are doing the right things or not. If you, by example, this can be click-through rate. If you have the application which you expecting, like to help the user take some of the actions in the application, and this is information. Okay, we're solving the people consuming, by example, more material, more content from your web page. Or you have the recall and the precision. For example, if you have the medical images and you like to say, okay, in that medical you have the diseases or not. Maybe the recall and the precision and situation where you not say the potential image with the diseases is okay. In that case, this can be your potential metric, and this is a very helpful if you're creating that kind of project, because first one, you can different if you're changing your solution, what is happening very often, you can make the testing. Okay, we are going with the positive things or not. Second thing, which is often happen in that kind of project, the different stakeholders in this kind of project not have the one definition of the success. That is, of course, this is apply also this normal software development lifecycle, where somebody put the model or put the application to production, but nobody used them. And from some of the persons say, okay, this is a success. From some of the people, no. Good to have this one metric, because everybody now in the project understand the success in the same way. And the third the positive of that performance metric is, if you're preparing the backlog and you're preparing okay, which is the potential, what is the potential next item which you should test or consider to the development, you can try to assess how to hit this universal performance metric. And if you say, okay, this is a potential big gain for the universal performance metrics, and that not in all the cases can say, this is our biggest effort for the development or for the data scientist. Maybe this is a quick win, but if you have the big gain in universal performance metric, you have the very big cost efficiency of that kind of project. Okay, if you set up this, thinking about the common tooling and infrastructure, and if you're working with the machine learning application, you are bringing two worlds together. The software world, the people who are working with the application, with the data scientist world, where is, I think, on a little different state of the maturity of the by example, the processes. Now the MLOps is something which is now applied more in that kind of world, where you have the full life cycle of the model, but still good to have the common vision. Okay, how we like to work with on that project together. Of course, Git repository to share your repository, also share the architecture of the model is one of the basic. Access to the data sets, and all the people who working on the project should have the access to all the data which is required in this process. And sometimes it's happening the situation, by example, regarding to the if you're working on the machine learning solution, very often you are working on the production data. Because if you like to have the representation of the good representation of your model, the model should work on the production data, you should have the subset, but that should be a production data. And from some of the reason, some of the people, by example, regarding to the national or the regional constraint, because by example, you cannot use the data coming from the different countries, and we have the cross-border restriction. Good to assess this on the beginning. All the people who are working on the model could use this data. Experiment result is if you are working on the model and they're preparing different version of the model, good to store the information about, okay, I prepare some of the experiment, make some of the failure, but if other person is working on the same problem, can look on this log and say, oh, okay, I not test this hypothesis again because I see this is failing. And that is now increase the efficiency of the project and make the good working model faster. Documentation, of course, you should have the Confluence and any other places where you're storing the information about the project itself, but the access to the previous projects and the access to the data coming from if you have by example, some of the experience in your company about the similar project, good to first look there, because the experiments preparing the computation of the models is very expensive in most of the cases. This is one of the most expensive part of this project, because this is also something which is uncertain from some of the level. If somebody working with the model, in most of the cases, you cannot say on the beginning, okay, that will be working or not. And if you like to reduce this uncertainty and increase the chance of the success of your project, maybe the best way is first look, okay, I have the similar project in the past, reuse all the experience which we have there, or starting from not on the 0 point, but you have starting from of the level which is gained in the previous project. And the access to the infrastructure, especially about if you are working, by example, on your models require the GPU, if you're working with the deep learning, first consider you have this kind of access regarding to the size of the data which you have. And the second thing, even you will have the access to the GPU in the cloud, think you have the budget for this kind of experiments. Because if you start working on the different hypotheses, the cost of the project will be increased. And in some of the reasons, somebody can say, okay, maybe we not like to invest so many time, and the problem which we are solving is smaller than the cost which is required to prepare that kind of model. Going next. Okay, I think this is batteries. Okay, something is wrong with this. Oh, okay. Next level next area word to consider, level of the automation. That means if you're thinking about the machine learning project, think about what is the expectation, how you like to replace or help the human in that project. As a baseline, trained as a human effort. That means we have no AI, we have the people who making some of the action, making some of the decision, and we are not involving any artificial intelligence. The second level is we using the artificial intelligence as an assistance, and in that case, the art model is giving you some clue, okay, what we can what we can be selected by the person, but human always is triggering the final action. And for example, the recommendation engine, if you have an next action, if you have the movies and you have the Netflix and you see all the potential movies to the watch, but the final decision is taken by the human. Okay, I triggered the action, I like to watch that movie. The partial automation is the situation where you, in some of the cases, the model decides for the human, in some not. For example, if you have the fraud detection system, if you have that kind of model, models can say, okay, we are almost completely sure this trait is not a fraud, and no action on the human in that situation. Or we say we are not sure, the model is not sure about that. That's the you are not sure about that this is a fraud or not. You have some of the level of some of the threshold of this of the certainty, and or this is that is the potential fraud. And in that case, you send this item to the action by the human. And the last part is the full automation, where you're working. You have the AI take complete control about your process decision. By example, if you're preparing the model to scale up the infrastructure, this can be a way where the model always decides for the human. And of course, you need to consider that is not something which you always go to the full automation, because in not all of the cases this is worth to go in that kind of the direction. But select this level of the automation at the beginning of your project. No harm, and this is also worth to consider on the beginning. No harm, that means your applications should not hit anybody which we're using that your solution. And we selected this for area. Fairness, that means if you're preparing the model and, by example, you exclude your data is excluding some of the group of the people from this model, the final model also excluding this behavior, this group of the people, and try to avoid that kind of bias. Data restriction. If you're working with the data coming from the different countries, think on the beginning you can use that data, because some of the cases you can say, okay, we're preparing the model, but regarding to the regional constraint, you have the GDPR and many of the other regulatory decision, and you on the end you say, okay, we have the perfect model, but you cannot use that one because from some of the reason the server is on the wrong country and you cannot process that kind of data. The compliance is this is something which is happening mostly in the big companies. They have their own framework for by example, the model lifecycle. And same situation with the data restriction. You have the model, but somebody from the compliance say, sorry, you cannot use that because somebody not reviewed the model before upfront. And good to consider this on the beginning, because sometimes this kind of compliance stuff can be complex and increase the time where you are going to the production with the model. And the ethics is more philosophical statement about the solution. But if you're thinking about the solution in the scale, if you like to, this application will be used, by example, you try to prepare the application will be used by the millions of the people. Think about you not harm these people in some of the way. And this is something which is a little blur, but if you're thinking about this kind of scale, make this question on the beginning rather than if you have this kind of application, consider this kind of problem during the production usage of this application. Model authorization is the next way. That is how you think about how you like to use the model, how you like to serve the model for the people. This is for the potential approach which you can have with the model. Binary version of the model. That means you have the model and everybody can download this model. You're not thinking about the UX, scalability, observability. People taking the model, run on your machine, see the logs. Second, the potential pattern is that if you're serving the model as a service for the other technical teams in your company. That means you not need to think about the user experience. You have by example, the Dockerized version, the Pug model in some of the Docker, and by example, in the Kubernetes, this is a scaling up. You can provide the observability and the access control for that kind of model. You can create a new solution. That means you embed the model in the whole application. And in that case, you need to thinking about the user experience of this application. And that is a little more complex, but the model is only one part of this solution. And the last pattern is the self-service platform. We have some of the experience with building that kind of platform where the models are created by the users, not by the owner of the application. And in that case, the problem is a little more complex because we need to think about the user experience, not only about the consuming the model, but also the building the model. And you need to think about how to provide the good data segregation to every tenant which working on the model has the same, not have any data leakage between the tenants. And on the end, thinking about the long-term maintenance of this kind of application, you have the team which is working with the ML, and this team be also available after the product launch? Because if data scientist is not available, the model very often degrading, and in that case you need to retrain the model and think about what is happening in that kind of situation. Because if the resources is not available, the people is not available, in that case you have the potential not usable solution on the production. Thinking about the scalability, that means what is your approach here to scale your application, how you like to measure the application, that's common for all the software development lifecycle, software products, and on the end, thinking about the reuse. That means if you're preparing a good solution, a good approach, you have the data set, labeled data set, how you can make this data available for other people, by example, in the company, or if you like to put this into the open source, how you can expose this information for the world. Because this helps the people who are working on the same problem to increase, make this more efficient. Okay, and let's go to the build phase. That will be more technical one. And Robert, please.
Okay, can you hear me? Great. So, in this phase, we will focus a bit on the build part, but we are not going to cover all the things and all the processes you have to do in order to create a machine learning system, because we just don't have enough time here. We'll just cherry-pick some of the concepts, some of the tips and tricks you can use that are maybe not that obvious, but that could make your life easier and save some time and effort. So at first, each machine learning journey starts with the data, and you have to know that if you create a model, then it's not your final model. You will have to retrain it, or one step on a time, or do it in an online matter, because the data changes in time. And it's good to understand how your data changes, how fast and in what way, to address these changes quickly. Also, in the phase of gathering the data, you, for example, if you're doing classification, of course you have to cover all the classes you have, but there is a high chance you will have an imbalanced data set. In this way, sometimes you cannot do anything, but sometimes you can work with your client to and ask them to provide you the data you need, and this solution is much easier than to create, for example, a more sophisticated model that could handle these kind of imbalanced data sets. When working on NLP projects, it's also important to cover all the templates, because mainly you will, if you work with some kind of documents, these documents can come in different templates, different forms, can have, for example, some slang, can have some different level of, let's say, language purity. Some of them can have errors. So it's good to know what you're facing and to be prepared for that. And here we can introduce the concept of data provenance and lineage. This is basically to know where your data come from, know and monitor all your data sources, because, for example, if someone changes the format of your data, it can degrade the performance of your machine learning model. And another thing is data lineage, which is the list of all transformation that is done to the data before they come to you. This is important because mainly when you deploy a machine learning model, it's not just a single service, it's probably some kind of a pipeline. And if your model starts to underperform, then the model can be just fine. The problem can be somewhere in the pipeline, and if you don't monitor it, if you focus only on the model, then it will be much harder to find and to debug. And it's also good to make some sanity checks and ask yourself a question, what can you be missing? Because you need to make sure your data is as representative as possible. So because you're just working on some little subset of data, and your job is to make it as good approximation of the real life data as possible. So look for something, maybe sometimes even your data can be too perfect. For example, if you're training some computer vision model on photos done by professional photographer, but then in production it's used by people using their smartphones, then the difference in quality could also impact the performance of your model. Another important thing to do is to maintain some kind of metadata for your data. For example, using tags. And using tags will make maintenance and debugging much easier. These tags could be actually anything. It could be a date where you received this data. It could be a batch of the data, maybe a type of this document, source, and many others. So let's consider a situation where you don't have any tags, and your model in production starts degrading. You see your metric has dropped, let's say 15% since last day. And you actually don't know where to start. You have to debug it, but you don't know where to start. But if you have maintained the proper system with metadata, then you could, for example, see that these data that you receive, that your model actually works well for most of the data with most tags. But, for example, the documents the PDF documents from Germany that are mostly low quality and using some kind of slang are the ones that spoil your performance. And you will be able to spot it really easily if you maintain this kind of a system. Data quality is also an important thing. And when we hear machine learning, we usually think about big data, because first thing we could think is probably big companies like Google, Microsoft, which train huge models with tremendous amount of data and ridiculous amount of computation. But the truth is that most machine learning engineers, most data scientists, don't work with these quantities of data. Your data sets, it's a high chance your data sets will consist more of 100, maybe thousands data points, not millions. And this is when it's important to have good data instead of big data. If you have millions of data points, then they will have some noise, but there's a good chance that most of this noise will cancel out. But if you don't have that quantity, then it's really important to find all the ambiguity, find all the mislabeled data or data that doesn't actually represent the real life data, and just fix it or get rid of it. And talking about labeling quality, most of the data sets are noisy, which means that they can be mislabeled, they can have incorrect or ambiguous labels. Here we can see an example of a simple classification task, which is to detect if an image contains a bridge, and we have a prompt saying select all images with bridges. So we have bridge here, but also this guy here is Jeff Bridges. So if we mark him, then probably it's an incorrect label. But this also depends on how you as a developer interpret this. But the example on the right picture is a bit more ambiguous, because we have two pictures of bicycles and one picture when there's no physical bicycle, there's just a drawing of a bicycle. And this is a question you have to answer yourself. Is this a valid bicycle or not? And you will encounter a lot of situations like this, and in order to solve them, in order to make them help to train your model instead of reduce your accuracy, it's good to have something called a labeling strategy. But before we talk about labeling strategy, let's talk about a bit about human level performance. So humans are really good at solving machine learning problems for unstructured data. So for example, things like translating some text, like summarizing the text, like having a conversation, things like finding objects in image. These are problems that are really hard for the machine, but for humans they're natural. So if we're doing some machine learning task on unstructured data, we are usually not aiming into achieving, let's say, 100% of some kind of metric. We're using it to achieving the human level performance, because usually it's really hard to beat this human level performance, or sometimes even impossible. And there are two types of this HLP. So one is when we know the ground truth, and this is how often the human discovers the truth. And the other is when we don't know the ground truth, it's how often two humans agree. So let me give you an example. Let's say we are having some kind of medical task, and we want to say if someone has a cancer. Then we can have the ground truth, which is that we're doing a biopsy, and the result of the biopsy is that, for example, this person doesn't have a cancer. Then we do some kind of medical scan, show this scan to a doctor, and then a doctor tries to predict what is the result of the biopsy. So this is human level performance when we have the ground truth. But if we didn't do the biopsy, but just have a medical scan, then we can give it to two different doctors, and then the rate when they, the number of times when they agree to what is the verdict, this is the human level performance when no ground truth is known. And this is actually good because we usually cannot do much about this HLP when we know the ground truth, but because then this this difference between 100% and human level performance is usually an irreducible error because, for example, the data is too noisy, maybe low quality, and so on. But if it's just that two people don't agree, we can actually do something about it. We can, by creating a labeling framework, we can actually make them agree more often. So what we should do, first we should evaluate what is our current consistency of our labels in our dataset. And to do this, we should go through our dataset and look for some patterns, look for some edge cases, look for some ambiguities. For example, like the one we've seen with the drawing of a bike. And then we have to be clear on how we should behave, what is the desired behavior of our labelers in this kind of situations. This way, we will increase the human level performance. We will make our dataset more consistent, and this way we will make it of a better quality. And in a result, we will train a better model. Sometimes instead of tweaking the model, instead of trying to build a more sophisticated, more powerful model, it's enough just to fix the data or improve the quality of the data you have, and that will give equal or even sometimes a better result than to train a more sophisticated model. Another thing to think about here is to use the right tools, because you could think of building an infrastructure for your labelers in your in-house, but there are already some ready-to-use tools, especially for computer vision and NLP, or you could even use outsourcing for this. If you don't have, for example, some regional constraints, then you can use things like AWS Amazon Turk, where you describe the task, publish the data, and these data are annotated or labeled by different people. Okay, so we've agreed that we need a labeling strategy, but actually how to do it. Let's say we have a situation like this. Our task here is to mark an area where there is iguana. And we have three labeling strategies that seem to be quite okay. The first one is we choose two non-overlapping rectangles, and there is an iguana in each of them. The second one thinks that, hey, but this iguana has a tail that goes right up to here, so let's increase the size of the blue rectangle. And the third labeler could say, but hey, they are close to each other. Let's just draw one rectangle to cover all of them. So the question is, which of these strategies is the best? And the answer is, the best strategy is a consistent strategy. it doesn't actually matter there. Your model, all of these three make sense, and your model will work just fine if you choose any of them. But the important thing is to choose one of them and to be consistent about it. And to prepare some clear examples, because if you have a new person arrive to your team and they have to label some data, then, for example, using these kind of images could help them to navigate on your dataset and to make the right decisions. You should also have just one single source of truth, which is this labeling strategy of yours. You should have it in one place, and you should make it easy to access and to update. Because as we've said before, your data is going to evolve, is going to change in time, and your labeling strategy should align to these changes of data, because as more data arrive, you will see new edge cases, you will see new situations that you didn't actually think you will encounter. And for these situations, it's also good to remember about metadata and tagging. Because the thing is that if you, there are a lot of powerful machine learning models now, which you can easily use, but the thing is that they don't make mistakes on easy examples. If your model doesn't perform well, probably it will make mistakes on harder examples. And the harder examples are the ones where, for example, human also is not certain what would be the label. And in this situation, you should have a list of tags discovered by, for example, browsing your data set. And you could tag your data points while during labeling. And this way, if you have a problem, then there is a high chance you will, when you look at the tags, you will discover there's, let's say, a red island of data points that don't perform well. And it will turn out that, for example, all of them are too bright, or all of them use some kind of slang. And if you tag these data during labeling phase, then it will be really easy to debug and maintain. So we answered the question, which is the best labeling strategy. So now let's try answering the question, is 85% accuracy good? Well, it depends. And to answer this question, we need to establish some kind of a baseline. This baseline could be a previous machine learning model that we want to exchange or upgrade. It could be also an existing implementation. Maybe it doesn't use machine learning and works only on a subset of data using some kind of heuristic. Or it could be just a simple POC you do in a, let's say, in 2 days or a week, using the simplest model possible just to see what is your starting point, because it helps you give the context, and also it helps you to assess your progress on your journey, starting from the baseline to achieving human level performance. And this is really helpful, because if after 2 months and using some heavy models you arrive at 85%, then it's probably okay. But if you're still stuck at 60, then it means that you probably did something wrong. Or it's just, or maybe it's what you can do, nothing better, and then it's maybe better to use the lighter, the easy and light version. And let's talk a bit about training. We're not going to cover like the whole training process, but we just picked a few tips that worked well for us. And first thing is to use transfer learning whenever it's actually possible, because there are these companies that train these huge models and then they share it with us. And it's really easy to take the knowledge gathered in these models and using just a small amount of data align these models to suit our needs. Another thing is active learning. Active learning helps you reduce the amount of time needed for labeling and for training by reducing your dataset size. And it's using your model to detect which data points are the most problematic before you even label them. And then you label just these most problematic data points, because as you may remember, I was saying that your model usually makes mistakes on hard examples. So this is the strategy which involves labeling only hard examples, because they carry more information and they will constitute more to your model's performance. Another thing that could speed up your labeling process is pseudo-labeling. If you already have some kind of a model on production and it works quite well, this is an important thing, that it already has to work quite well. You can actually take your new batch of data and pass it through this model. It will predict some kind of labels for your new data, and then your labelers, instead of labeling all the data from scratch, they could just accept or correct your model's output. And this way, if your model already works well, it will save them a lot of time. But on the other hand, if your model performs poorly, it will just add them more work for correcting their mistakes. And the last thing here is determinism. So your models probably will fail someday. And when they do, you need to know why. And for that, it's good to have all the seeds fixed, because if your model fails during training and then doesn't fail, then it may be really hard to reproduce. But if you have control over all the random things that happen, like weights initialization, by controlling the seed, you can actually, in your controlled environment, you could try to reproduce these steps, and it will be much easier to find an error. And the last thing here is to start from light models. I told that you should use transfer learning, but you don't really have to start from models like BERT large with weight more than gigabyte. You can start from something lighter. Even you could even use it as a baseline, and you can go to even to BERT tiny, which is 16 megabytes. So it's like 100 times smaller than its large counterpart. But if you're using if your problem is not that complex, it already may be enough. And last thing we will talk today a bit about is maintenance. So your model doesn't actually do anything until it's deployed. And deploying machine learning models and maintaining this kind of applications a bit different to maintaining, let's say, a backend service, because it's like adding one layer of complexity, one layer of things that could go wrong. Let's say you have a service that serves photos. You don't actually, if it's just a backend service, you don't really care if this photo is too bright or too dim, or maybe if it's a good quality. But if you have some machine learning on top, your data could be valid, but you still can produce bad results. And there are several things we could do here. There's, for example, A/B testing, where you deploy different versions of your model to mostly to verify different hypotheses. There is also very useful shadow mode deployment. It's where your process is behaving just like before. So, for example, a human is doing something, but in the background, in parallel, you run the machine learning model just to evaluate how it behaves on real-life data, because the data changes. So by the time from the moment you start developing your model to the moment where it's actually built and ready, the data can already be different. There could be a data drift, and then your model is actually useless. And there are also some other options like canary deployment or blue-green deployments, and canary is a rolling deployment where you first route just a few % of your traffic to a new model and monitor what's going on. So it's like testing on production, but it's better to fail on 2% of the traffic, not on 100%. And blue-green deployment is about having the duplicate version of the new and old model and just route the traffic to the new one, but if something goes wrong, easy rollback to the previous one. And last thing for today is monitoring, because it's also a bit different than monitoring just a regular backend application. And here you should answer some additional questions, like what are the things that could go wrong with your data, what are the things that could go wrong in your model, and how to detect that the data or the concept we're trying to catch have changed. So, of course, we also need some system metrics, but apart from them, it's also good to monitor the input of the model and its output. And for the input, it depends what you should monitor. Sometimes I mean, for each use case, you should just sit down and brainstorm on what what could go well. For example, you could monitor the image brightness. You could monitor the volume of speech for speech recognition applications, or some kind of background noise. You could monitor the average input length, the number of out of vocabulary words for NLP applications. And for the output metrics is something about there are actually two types. You could either monitor the exact output of your model, or monitor what happens after a user gets their response. So, for example, if you're developing a search, you could measure how many times a single person types the query, because if you can make an assumption that if they want to find something and they get it quickly, then they will type it only once or twice. But if suddenly a lot of people start typing the query 10 times, then probably something went wrong with your model and they're getting wrong results. Okay, let's change again.
Okay. Okay, and the last slides on that presentation is about the reuse everything. And that is the solution which is very nice and test in our environment. That means if you can reuse anything from your project, let's do that. Because this is first decreasing the cost of this delivery. Second one is decreasing the potential uncertainty which you have in the machine learning project. And the third one, if you have, for example, the solution, maybe this is not worth starting from the scratch. And this should be, I think, the first and the most important beginning point of any kind of machine learning project. So look first, we can reuse something from the past, experience, models, data, and thinking about what you can do to reuse this, how you make this your data or your work reusable for the other people in the future. And if you're going with this approach, you are building some of the capabilities in the company in your area, and next project will be much easier. You have the bigger chance of the success, and in many cases you can get the very good gains without the big effort from the team. And that is the reducing also the magic around the machine learning, where people expecting some of the great results without the big effort. And yeah, that is all for today. That is the summary of that. And question, I think we are out of the time. That means we'll be available on the UBS stand for the next 1 hour. If somebody like to know more or will have some of the question, happy to meet you there. Thank you for today.